How you doing, everybody? Randy Richard in the shop. Table saw restoration. This is the motor. We're going to get it all disassembled, figure out what we need to do to it. I imagine the bearings I'll probably do for sure. I think it has ball bearings. It says it has ball bearings. Now, that's what we're going to do in this video, is attack this motor. Yeah. So this winding is at 250 volts. I'm just going to do 250 volts. We're about 300 megs, 400 megs. So that one's okay. Then you go to the other winding, and we get 0. That's not good. How you guys doing? Randy Richard in the shop. And here's the motor. This is for the table saw joiner combo unit restoration. And I got this motor from Gary Brown, Old Iron Machine Works. He's been very generous to me on this project. He donated the joiner and a bunch of other parts for the saw. So we got this one. He says it runs. It's in tough looking condition. Let's take a look at it. Let's get it apart, figure out what parts we need, and then we'll be back. 1 horse motor, dual voltage, 110, 220. I don't have my glasses on. There we go, 220 volts, 1725, frame 182 motor. So 40C continuous rating, single phase, 60 cycles. Draws 13 amps on 110 max and 6.5 amps on 220. Like I said, it looks tough, but I think we can get it cleaned up. It'll take a bit of work. We're going to get these pulleys off. They had dual pulleys over here. One's all loose. It has the original switch, which is unbelievable, and a nice 7-inch pulley on this side. So let's we'll start taking this apart, and I'll get a picture here of the nameplate for you, and we'll also see if we can get this off so we can really do a good job cleaning this up. Now Gary says this runs. I plugged it in. No sparks. Let's see. It worked. That's a good sign. I'm going to try to get these pulleys, I think, off first. Moves. Success. Okay. Along with the mud daubers. So before we do anything, we're going to make this ground here basically ground, to the motor frame somehow. And then we'll just go to each lead like that. Alright, right there I have it set at 250 volts. Let's bump it up to 500 volts. And we're reading, let's see here. This is the top scale. And 200, almost 250 mega ohms. So 250,000 ohms. So that's pretty good. Yeah, it's 500 volts. It's mega ohms, and it's just 1 times 1, right? Otherwise, you'd be divided by 2 or multiply by 2 at 1,000 volts. There's no need to push this insulation. And we're going to go to each lead and test them. And we should hopefully get good readings on all of them. Right? We are golden as far as that goes. Unlike the other motors. Now, these are in pairs according to the drawing up here. So I can only identify really for colors 2 of them, the black and the red. So I have to assume yellow and green are the other ones. And I'm going to tie wrap these together so I know how they are for 110 volts. Because that's how we're going to hook it back up, 110. Now, these motors have brushes in them. This is a Repulsion induction motor. So, we need to carefully disassemble this. This is the rotor from the other motor, the 3/4 horse motor, and just to show you what it looks like before we take it apart. But there's a commutator, and there's a brush ring that goes around here, and these are like the shorting brushes. So that goes in there. And these are very important on how these go, on what angle they're at for maximum efficiency of this motor. This is a very old style motor. You don't find these kind of motors anymore. But this is what this looks like inside. Cover here. And we can see the brushes inside here. I'll try and put a little bit of extra light on it. Right down here is the commutator. Yeah, right down here, this dark spot. And you can see the windings of the rotor right there. And then it's the brush rig here. Alright, down in here there's 2 screws, and those hold the brush rigging onto the end bell. We're going to see if we can get this all loosened up. Now, before you take apart the end bell of a motor, mark it. Now, actually, I see someone put a little chisel mark right here and in the motor already. It looks like a witness mark, but I'm going to put, actually somebody did already here. So this motor's probably been apart before. There's 2 center punch marks right there and 2 ones right there. We're just going to freshen them up a little bit. So somebody else has probably had this apart. So, probably to service the brushes. We'll see if there's... Yep. And there's 1 center punch on this end. Right there and right there. So, we are all good on the marks. think this has been sitting in Gary's container, storage container, for a long time. There you go. That end's free. It's only in there about 1/8 of an inch. Not very much. Oh well, the whole works is coming out, so we'll just gently slide this out. There we go. Motor's full of sawdust and shavings. There we go. We'll just slip the brushes off. Oh, good looking brushes. The commutator is very dirty. Probably been sparking a bit, but it's been probably sitting here a long time. So we'll have to do a little cleanup on that. Right now, I'm all concerned about is what bearings do I need to get. So I want to get these bearings off. And we'll knock that other end off and vacuum this out. Now it's a bunch of cleanup to do. Get everything cleaned up so I can paint the inside. Is the inside coating is really good looking. We'll just kind of clean it. Yeah. I might have to. Those are looks like drive screws in there. I don't know if I can take that out or not, but I'll try to get that washed and cleaned out. And these are the little locators, pins for locating the brush rig at the right angle. So only the other end had a spring, you know, felt washer and a spring washer in there. Here's my high-tech puller rig. Some parts made, some parts bearing puller plate there, and parts of another puller. So, you know what? It all works. Alright, motor is obviously completely disassembled, but I've got the nameplate off, the data plate, which is a little bit of a chore because they used like one of the drive screws, but they were actually small nails. They looked just like a drive screw, except it was a nail point that were in there. So I got that all off and cleaned up. It's amazing. This side really was in pretty good shape, but this side has gotten rusted and pitted, so it must have had some water damage on it at one time or something. But the insides is absolutely great, all cleaned up, and it may have even been, it's such good shape. I wonder if it was rewound at one time, possibly. It's awful good shape. And them bells are cleaned up, ready for paint. Insides, they put that on there with a drive screw, so I couldn't take it out. I didn't want to take it out. But good shape, ready to go. Well, bearing should be here sometime this week, and I'll be able to get it assembled. Armature is right here. You know, this is the rotor. So this has obviously been worked on before. They've cut the commutator at one time or another, and now there's only a slight feeling of any wear, but the mica is up to is flush with the surface of the commutator, which is not good. It should be undercut. So I'm working on that right now. I'm doing this all by hand. I don't have an undercutting machine or anything like that, so I'm just doing this by hand. And we'll do a little talk about that. So that's coming along, and we'll get that hopefully done this week. I'm about a quarter of the way on that, so it only took a couple hours. The internals of the motor, this winding is just in awesome shape. It's looks perfect. Meg's perfect. So, I mean that's great. It looks like it's it was dipped and then the whole winding was pushed into the motor. Just from the scrape marks you can see. But this grommet right here has slipped back through the casing, and so the wires down in here have a little bit of a wearing issue here. See here, especially the red one down here and this white one and even the black one, and there was some tape here, so it had some issues there. I think they're all fixable here, but I need to get that grommet so it's up to protect it when it comes through the case. All the tape was falling off, so it's old and very brittle. This is some friction tape here, and yeah, I'll fix all this up here. So we're going to get that grommet up. So this is where the wires come through the housing of the motor, and this grommet here has slipped down, and over on this side, two of the wires, the red and the white over here, have it's caused a little bit of wear and damage down here, and the red one, the conductors are kind of showing. So, and the white one's got some bad spots, and the black one here has got some bad spots. So, I don't know if there's enough slack to push these up a little bit. I think there is a little bit. So maybe I can gently, but I got to get the grommet back up through the housing so we can get some heat shrink tube around these wires to protect them. They're kind of old. They're not super brittle, but they are delicate. These are the wires here where they're coming through the motor. Down in here is the grommet itself, and these are the leads. There's not much slack in them. Maybe I can get some more, little bit pushed out so I can get some heat shrink around, but I got to get this grommet thing needs to be fixed up here. Alright, I had the grommet up there, but so I've slipped this piece of, what is this, quarter or so, 3/8 heat shrink on there, and I was able to slip it over the lug, and I'd like to go a little bit farther with it if I can. If I can get it through the motor, through the grommet, it'd be nice, but I don't think I can. It's so tight. This really tempts me to pull these wires out, put on new leads, and run them up through. Oh boy. Then I can fix that grommet. Well, I just so happen to have some perfect wire for this, and I need a red, green, black, and a yellow as their wire colors they used on the nameplate, so white would suffice for the white and all the rest. So I think I'm going to try to get those out, and we got plenty of lead length here. That's about about 10, 11 inches, and I'm going to extend those wires. Alright, I'm going to try to sneak these out of here. This is going to be a slow process, but once I get one out, I'll be really, really good shape. This is going to be the easiest one, I think. Alright, that's good. That's the yellow wire. So we're just going to kind of leave it out here to the side. Now the black. You can see how bad they are. This one's clear down here to the insulation. So they're pretty bad, pretty tough shape, as you can see. But we'll cut them off here, these where they're bad, and add on. Here's the quote-unquote grommet. Yeah. And we'll see what we can come up with. If I oh, this is really a hard one. I don't know if that's rubber or a plastic thing. If I have to, I'll make one out of Delrin. And got to have something. These are very sharp edges on here, so you got to have something in there. Pretty much that's it. Just be very careful of these. These are brittle, you know. But this is going to work out. So far, so good. Alright, I found some nice neoprene hose. And all the wires seem to fit quite nicely. I can slip them through at least. And so we'll put a piece of, we'll just put that down in there. We'll cut it plenty long. I've stuffed them through the hole. I found a piece of hose that will, these will all fit through, and we'll put that in there afterwards, after I get these kind of situated. I've pushed these down, laid them in here, and now I'm working on these, and then I'll tie wrap them so they can't move. I'm just being really, really careful with these. They seem to allow me to bend them a little bit, so. This one spot has a little bit of brittleness here, and I'm just going to put some friction tape around this to get some protection here. use some of this Dow Corning number 4. It's an electrical insulating compound. It's a light silicone grease kind of stuff with what it is. I rubbed some of that on the wire to make that slip on there really nice and easy. And very nice fit. And I got it in there about 1/4 of an inch, so that is probably going to stay there. It's really in there. I can't really get it in there any farther, so. But it's better than what it was. Way better. And now we'll go into the box, and it should be pretty good. Now I got it all together, and we'll do a little Megger test just to make sure everything's good. And 500 volts. It's infinity, which is nice. Same. Okay, so that's good. Okay, we make out great. So we'll be rocking and rolling here. Hey you guys, this is the end of part 1 of the motor. I'm having to split this video into 2 pieces because we are having such internet troubles here with them putting in new lines and all that, so I'm lucky to get something in 30 minutes uploaded. So I don't have to start over and over and over. So I'm going to be breaking this one up into 2 parts. The second part will be out the day after this one comes out, so we'll get them both out and uploaded in time. So thank you guys, and thanks for understanding.